I am Takayoshi Hachijo from Sims Corporation. In this study, I present the development of autonomous robots for construction. Today, this is today's outline. First topic is introduction. Japanese construction industry is facing a labor shortage. So our missions are improving productivity and solving the labor shortage. So now I explain the installation of ceiling board construction work. A plasterboard weighs about 40 kilograms. An area per single plasterboard is about 1.6 meters squared, and metal foundations are made of steel. And these figures are a procedure of installing of ceiling boards. Generally, a pair of workers install ceiling boards. This is hard work because it involves the working at high price. Moreover, this work requires experience and skills. So I explain a pair of robots for ceiling board construction. The left robot is an autonomous mobile robot composed of two industrial robotic arms. One has a laser sensor and a screwdriver, and the other has vacuum parts to grasp the plasterboard. And the right robot supplies board materials. Both robots can recognize self-location with 2D LiDAR and move autonomously to destinations. And this movie shows a procedure of robot work. First, they move to destination. They set the outrigger and lift up. And they start the ceiling board construction work. The right arm measures plasterboard supplied by assist robot and measures plasterboards and the metal foundation on the ceiling. And now measuring. And the right arm and the left arm grasps the board and press into the ceiling. Now the left arm is grasping the plasterboard and press it. And the right arm fastens the plasterboard with tapping screws. So finally, if they finish the ceiling board work, they move to next destination and execute this sequence again. And this movie shows the result of the robot work in our case study. We applied a pair of robots to our construction site in Japan in March 2023. We constructed 123 meters squares in this construction site for 8 days, including our experiments and so on. We confirmed the robots installed correctly, and there were no gaps between the plasterboard. The raised floor construction work is to store wiring and piping by providing space on the floor slab. Pedestals are installed to adjust the height, and panels are laid on the top of on top of them. This work requires a physical burden on the waist because workers must constantly lean forward to perform the task. Similar to the ceiling construction robots, the floor construction robot is an autonomous mobile robot composed of two robotic arms. One has an arm to pick up pedestals, and the other also has an arm to pick up panels. The right robot is an assist robot to supply the materials. And this movie shows the procedure of robot arm. First, the right arm picks up a panel and installs on the pedestals. Next, the left arm picks up a pedestal and dips into adhesive to bottom surface of pedestal. A box containing adhesive is prepared on the assist robot. In addition, removes excess adhesive by a comb at the top of the bottom, and the top of the box. Next, the left arm installs the pedestal according to the floor line markings, and adjusts the height according to the laser level. The robot repeats these actions and autonomous movement. On this site, we carried out 570 meters square, excluding near side of walls and columns. The robot installed each pedestal in 1 minute 40 seconds and each panel in 1 minute 35 seconds. Although the procedure differs from human work, the robot was able to perform the equivalent of 1 Monday's worth of installation in 1 day. From our case studies, we discuss 4 statements to introduce of the robots for construction site. First, about self-localization. In the construction site, the environment changes daily. So the robot localization may be an issue. We enable self-localization system by using the drawing of buildings. The black line, local map date created by the CAD drawing. The red line, point cloud data obtained by 2D LiDAR. This system enables autonomous movement with an accuracy of about plus or minus 50 millimeter. Second, about cooperation. Actually, our robots cannot replace all human works. Therefore, robots need to work in cooperation with workers. Our robots are designed to work in the same environment as people. And they can move autonomously without special preparation. And when robots install the ceiling board, they can detect and avoid openings for equipment. And when robot installs the pedestals, they can use floor line markers that are also used in human construction. A third, about safety. The robots are equipped with some safety sensors. If the sensors detect an obstacles or an opening of floor, they ensure safety and allows robot to slow down or stop. And they can stop all operations immediately in case of collision. While the robots are working, the obstacle sensor interferes with robot's working range. Therefore, the obstacle sensor is switched off only during work. However, the robotic arm cannot detect collisions and cannot be stopped emergency. For this reason, the work area is separated from the area of workers by safety fences. This is our important future work. When introducing robots to construction site, in addition to the deployment of sensors, collaborative robots are desirable. Last one, about effects. The daily working shift are about 6 hours in Japan. Compared to workers, robots may work slower and less efficiency. However, robots do not tire, so allowing for overnight operations. By replacing repetitive tasks with robots and assigning workers to more detailed work, cooperation between robots and workers can achieve more efficient and less burdensome operations. Thank you. I want to talk more, but I'm sorry, I don't have enough time. And please email later. Thank you.